You send a message to a Kafka broker. The acknowledgement is lost in transit. Your producer retries. Now, two identical copies sit in the queue. The consumer processes both, triggering side effects twice: a duplicate charge, a double email, corrupted data. This is the crisis. Every distributed messaging system, Kafka, RabbitMQ SQS, delivers at least once under failures. Duplicates arise from retries due to lost ACKs or crashes. Exactly once isn't a broker guarantee, it's a consumer-side problem. No matter how many times a message arrives, the observable side effects must happen only once. Therefore, we need explicit deduplication. Stripe's pattern handles real money, so it can't afford errors. Here's how it works. The client generates a unique idempotency key, like a UUID, and sends it with every API request. Retries reuse the same key. On the server, it checks a cache, say Redis, for this key. If the key exists and the request completed, it returns the cached response instantly. If the key exists but the request is still in progress, it returns a 409 conflict. If no key is found, it processes the request, stores the response with the key, and sets a time to live, typically 24 hours. This TTL bounds storage growth while covering realistic retry windows, critical for payments. But publishing events reliably introduces the dual write problem. Updating a database and sending to Kafka sequentially risks inconsistency if a crash occurs in between. The transactional outbox pattern sidesteps this. Write the event to an outbox table in the same database transaction as your business data. Since both writes are in one transaction, they're atomically consistent. No distributed transactions needed. Then a change data capture tool like Debezium tails the database's write-ahead log, reads the outbox rows, and publishes them to Kafka. This ensures events are published exactly once from the database, though consumers still need idempotency for duplicates from CDC restarts. However, idempotency gets tricky with non-deterministic operations. Take timestamps. Now, returns 10 o'clock on the first try, but 10:05 on a retry. Different results each time. Or random IDs. A confirmation code generated anew on each attempt. External API calls are hardest. You call a shipping API, it succeeds but the response is lost. Retrying creates two labels. The fix? 4 timestamps and random IDs. Store the original result from the first execution and replay it on retries. For external APIs, use the provider's idempotency keys if available, like Stripe or Adyen do. Key takeaway: capture and replay the original outcome. Deduplication alone isn't enough when operations vary.